Hey everyone, welcome to 4.4, which is de Moivre's theorem. And here's de Moivre's theorem in case you haven't written it down yet. If z equals r cosine theta plus I sine theta, that's just a complex number in trig form. If it's a complex number and n is a positive integer, then z to the n is going to equal that whole thing to the n, which then if we distribute the n to everything in it, it's going to be r to the n cosine n theta plus I sine n theta. So what we're going to do is we're actually going to use this. What we have done before, previous to this, is we added numbers, which we did a while back, then we multiplied and divided. Now we're going to say is what happens if you multiply the same one over and over and over and over and over again? Well, de Moivre figured out that there's actually a pattern. So we're going to use his theorem to find out -1 plus square root of 3i to the 12th power. What we need to know is we need to know two things. We need to know r and we need to know theta. So what we are going to do for r is to take -1. We're going to take the square root of -1 squared plus the square root of 3 squared. So we end up with r is going to equal 1 plus 3, which is 4. So r is going to equal the square root of 4, which is 2. So we have r. Now we need to know what theta is. So what we're going to do is I'm actually going to just graph this really quickly. It doesn't have to be any sort of real sketch. It just has to give me an idea of what quadrant I'm in. So if I go -1 square root of 3, I go -1 to the left, up square root of 3, that's going to be the point. -1 square root of 3. So I want to find out what theta is. So I'm going to do opposite over adjacent. So I'm going to use tangent of theta is going to equal the square root of 3 over -1. And then I say I'm going to use this side, this thing right here, and I'm going to find out where is tangent equal to negative square root of 3 over 1? Well, it is here, and it's also, again, down at 300 degrees. But because I know I'm in quadrant 2, I know that theta should be 120 degrees, which is the same as 2 pi over 3. So I'm going to make it 2 pi over 3. We're going to keep it in radians. Could you have it in degrees? Sure, but it's not really a big deal. I like radians. We're going to keep it that way. So I know what r is. I know what theta is. So let's use his formula right here. So we're going to say that this number to the 12th power is going to equal r to the 12th power, so it's going to be 2 to the 12th power, and it's going to be times cosine of n theta. N is 12, so it's going to be cosine of 12 times 2 pi over 3, plus I sine of 12 times 2 pi over 3. All right? And since I put that one in parentheses, I put this one in parentheses, and now we'll just keep on going. 2 to the 12th power, I'm sure you can just evaluate that, and what you get is 4,096. Cosine of 12 times 2 pi over 3. The 12 and the 3 are just going to cancel out to be a 4, so it's really going to be cosine of 8 pi plus I sine of 8 pi. All right? Now if you think about 8 pi, if I'm talking about a circle, I know that 2 pi is once around. So I'm really going 2 pi, 4 pi, 6 pi, 8 pi. So I'm really going 4 times around the circle, and I'm ending up back at cosine 0. So cosine 8 pi is the same as cosine of 0. So we're going to say this is 4096 times cosine 0 plus I sine 0. Put that in parentheses. And cosine of 0 is going to be 1. Sine of 0 is going to be 0. So it's going to equal 4,096. Because if I multiply this as a 1, this one's a 0. I multiply the 4,096 by 1, 4,096 by 0, and I should end up with just 4,096. So if this was ending up being a different number, you would just multiply the 4,096 in, and you get an answer. Way easier than multiplying it by itself 12 times or trying to do anything else. Okay? So your assignment here is to find 1 plus I to the 5th, and I would like you to write your answer in standard form. Your answer in standard form is exactly what I did here, plus 0I would be another way of writing this in standard form. All right? So, there you go, and good luck.